Today we're going to talk about proportional and non-proportional relationships. It's really simple. I know you all, it's been a while since we looked at unit rates, but a unit rate is just a ratio with a denominator of 1, and you get it by dividing. But we're going to talk about that when we go through this lesson. So let's just go ahead and get started with proportional versus non-proportional. All right, guys. A proportional relationship is a relationship between two quantities in which and I want you to write, ratio of one quantity is equal or the same as the other quantity. So again, we're doing this online, so make sure you're pausing the video and you're taking notes. Keep it in your notebook just like you normally would if you were in school. So just pause it, take notes so you can keep it with me. All right, so it says a proportional relationship is a relationship between two quantities in which the ratio of one quantity is equal to the other. And you're probably thinking, I don't know what that means. Okay, it doesn't make any sense to me. All right, so write this down. In other words, these quantities always maintain the same ratio. That is, when you divide, and you all know when we find a unit rate, we divide. When you divide any pair of two values, you get the same number. And we'll talk about that in just a second so it'll make sense to you, okay? All right. There's a part here that says in the activity you just completed, well, we didn't complete an activity because we're not in school. So what I want you to do is scratch that. We're not doing that, okay? Not doing that at all. We're just not even going to worry about that. Now, if you were in school, I would have had you complete this activity that goes along with this lesson. But we're not in school. Like I said, we're going to go ahead and just continue on. All right, so I'm going to try to explain this. It says, in other words, these quantities always maintain the same ratio. That is when you divide any pair of two values, you get the same number. So you're going to take two values and divide. And whatever two values you take and divide, if you continue to take two more values and divide, and those numbers end up equaling the results, then it's proportional. Let's just take a look at example 1 so you can kind of get an idea of what I'm talking about. It says Alberto types 45 words per minute. Is the relationship between the number of words and the number of minutes a proportional relationship? Okay, and we're going to talk about why or why not. All right, so just taking a look at this, what we want to do is divide. So we go back up here and it tells us, basically, we're going to divide any pair of two values. Now, what two values are we going to divide? Well, we're going to divide words and minutes. And as you can see, they're in the table right here. There's words and there's minutes, time and minutes. Okay, so we're going to take words and divide it by the number of minutes. And we're going to do that for each one of these columns. So we're going to take 45 and divide it by 1 because there's 45 words and the time for 45 words is 1 minute. 45 divided by 1 ends up being 45. Then we're going to take this one. Okay. So the number of words here is 90. So you're going to take 90 and divide it by the number of minutes. The number of minutes is 2. Well, when you take 90 and divide it by 2, you also get 45. So far, I'm taking two values and dividing them, and the results are the same. So far, this fits proportional, but I just need to continue all the way through. Okay, now I'm going to look at this column. So someone can type 135 words in 3 minutes. Okay, so if they type 135 words in 3 minutes, that's also equivalent to 45 words per minute. Okay, now look at this one. All right, you can type 180 words in 4 minutes. 180 divided by 4 is also 45. Okay, last one. We've got to check all of them. You just can't check a few and say, oh, it's proportional. All right, that's 225 words typed in 5 minutes. Well, that equates to also 45. So if you're looking at all these ratios, basically 45 over 1 is 45. 90 over 2 simplifies to 45 or 45 over 1. 135 over 3 simplifies to 45 or 45 over 1. 180 over 4 simplifies to 45 or 45 over 1. 225 over 5 simplifies to 45 or 45 over 1. So since all of them are simplified to 45 or 45 over 1, we say these ratios are constant. In other words, they're equal to each other, okay? They're the same. All right, with that being said, you all know that when we divide, we're actually finding unit rate. Well, notice I kept saying 45 over 1, although I wrote 45, 45 over 1, 45 over 1, and so forth. All right, so this common ratio is known as the constant proportionality. All right. So it says, write this ratio below. Well, what ratio did we find? What constant number did we keep getting? Well, we kept getting 45. It was 45 over 1, although I said 45. That's basically 45 words per 1 minute. But that's your constant of proportionality in the table above. Because it's the number that you constantly keep getting. So because we constantly kept getting a ratio of 45, we say that this relationship is proportional. Now, if I were to go back up here and look at one of these, and let's just say, I'm trying to make it a different color. All right. So suppose one of these had not been 45, like maybe 90 divided by 2. If they didn't give us 45, then we would have ended up with, instead of a proportional relationship, it would have been a non-proportional relationship, which I think the next problem is going to be something that looks like that. So let's take a look at it. But, in this case, all of them ended up being the same ratio, which was 45. And you all keep in mind, when we're doing this, when you divide, you're also finding unit rate. So I'm just going to go ahead and tell you the constant of proportionality is just your unit rate. However, it needs to be the same all the way through. All right, let's just go ahead and take a look at some more. Let's get to the next page. All right, bear with me, guys, because I'm learning this. This is new to me. All right, let's take a look at this one. All right, so this one says that the table shows the distance that Allison drove on a day of her on one day of her vacation. So we want to know is the relationship between the distance that and the distance that she drove and the amount of time that she drove, is it proportional? Why or why not? Okay, now as you can tell, my table got cut off. So this really should say distance, and it's in miles. And this is time in hours, okay? All right, so we're going to take distance and divide it by time. And I know some of you might be saying, well, how do I know which one to divide? Should I do 1 divided by 65 and 65 divided by 1? And that's, suppose I didn't tell you already. So I already told you right here how I want you to set it up. So in the next lesson, I'm going to explain how you would know which one is the numerator and which one is the denominator. But for right now, I'm just going to tell you which one is the numerator and which one is the denominator. But like I said, next lesson, I'm going to help you to be able to pick it out on your own. All right, so all we're going to do is take each one of these, the distance, and divide it by the time, okay? So the distance here is 65 miles. Someone went 65 miles. And they went that far in 1 hour. So 65 divided by 1 is, I'm going to put 65 mph for 65 miles per hour. All right, now we're going to take a look at this one. So someone went 120 miles, but it took them 2 hours, okay? Well, if you can go 120 miles in 2 hours, that means you're going not 65 miles an hour, but 60 miles per hour. Okay, because 120 divided by 2 is 60. You can just stop right there. You don't even have to check this one. You don't have to check this column, nor do you have to check this column automatically, because when I found the ratio of each one of these, where you had distance and hours, when I found the ratio of each one, this quantity ended up being 65, whereas this one ended up being 60. They're not the same. So automatically right there, I know that these two are not proportional. All right. Not proportional. And why is it not proportional? I'm going to put BC for because the ratios are not constant, which basically means that they are not the same. And these ratios we're talking about, there is no constant of proportionality in this one, because constant of proportionality will indicate you would have a constant. Well, that's 65 and that's 60. So there is no constant there. So we can't say it's a constant of proportionality. All right. Let's go down. It says, do you think Allison drove at a constant speed for the entire trip? And you just think about real life and a real life experience. Like if you're driving, I hope you're not driving yet, but if your parents are driving and that may be going to Birmingham or someplace like that, are you constantly going the same speed all the time? Do you think they'll be constantly going the same speed the whole time? So would someone be going 65 miles per hour all the way from Coosa to Birmingham? Well, no, that doesn't make sense. Because you got stop signs, you got red lights, you got traffic. Some people may speed until they see the cops. Okay, so you're going to slow down at some point and you may speed up at some point. All right, so it says, do you think that she drove at a constant speed? So we were going with no. Now, if you were in class, I'll just have you tell me the reasons why. No, because she may encounter traffic. And what else did we talk about? Encounter traffic. red lights, um, law enforcement. You all know we get scared when you see law enforcement. Excuse me, let me take that out. You hit the brakes. Nobody wants a ticket. ETC, which stands for etc. That means several things that could happen that could cause her to slow down and speed up. All right, so we see an example 1. I don't want to go up that page, but if you go back to example 1, if you look at it, all the ratios were the same. So it was a constant of proportionality. It was 45 words per minute. Example 2, there is no constant of proportionality. You went from 65 miles an hour to 60 miles an hour. Okay, yeah, like I said, you bear with me. All right, let's look at example 3. The Vista Marina rents boats for $25 per hour. In addition to the rental fee, there's a $12 charge for fuel or gas. All right, so they're going to charge $25 for every hour that you rent the boat, but you also got to put gas in the boat. But what we want to do is take a look and see if the number of hours, if the number of hours that we rent the boat is proportional to the cost. Okay. All right, in other words, am I going to get the same thing if I take my cost and divide it by the number of hours for each one of these times? So let's just see. Well, if you look at the table, I got some information that's missing. Whereas in example 1 and 2, I had all the information in the table. But we can use common sense and figure out what goes in the table. All right, so let's suppose you want to rent the boat for 1 hour. Well, what do you have to pay if you rent the boat for 1 hour? Well, it says you have to pay $25 for every hour. So you're paying $25 for every hour. Trying to get a highlighter. All right, so you're paying $25 for every hour. So that automatically means that you paid the $25. Well, what else do they want? Well, these people said, well, you also got to put gas in because they're not going to pay for it for you. So you give them the $25 to rent the boat. Then you give them the $12 so they can put gas in. Because like I said, they're not paying for it for you. So that means that you have to pay a total of $37. Okay. All right. Now, suppose you say, well, I really don't want to do an hour. I want to stay out there a little longer. I want to stay out there for 2 hours. Well, again, you're back at $25 an hour. So you got to pay $25 for the first hour, $25 for the second hour, but you also got to pay for gas. Again, they're not paying for it. All right, that doesn't mean you pay $12 for gas the first hour and $12 for gas the second hour. It's not like you're out there on the boat, then you come back and say, oh, let me go back and get gas because I'm keeping it in the second hour. So let me get $12 again. No, that's not how it works. This is a one-time fee, okay? That's one time. When you're out there on the water, they're not going to make you come back to put some more gas in. Now, if you run out, then that's a different story. But this is a one-time fee. All right, so you paid $25, which is $50, and 50 plus 12 now means that you have to pay them $62 if you want to keep the boat for 2 hours. Now, but if you want to keep it 3 hours, well, you have to pay 25 basically times 3. Pay it 3 times, which means you're paying $75. Plus, you got to put this gas in. So if you take 75 and add 12 to it, that means that you're paying $87 to keep it for 3 hours. Okay, so now we got our table filled in, so we can divide like we said we would do in order to find these ratios. All right, so let's divide cost by time. So this cost here is 37 and the time is 1. So 37 divided by 1, of course, is $37, and it's going to be per hour, okay? Just for that column. Now I'm going to take a look at this. Well, if we keep the boat for 2 hours, going to pay $62, and that's $62 for 2 hours, like I said. So 62 divided by 2 ends up being $31 per hour. Well, I can stop right there because these ratios are not equal, okay? These are not equal. Ratios not equal, okay? So that means that this is not proportional. It's just as simple. Basically, take your two values and divide. If you continuously get the same ratio when you divide, proportional. If you take the two ratios and divide, but you don't get the same result or the same ratio when you divide, not proportional. It's just that easy. All right, let's go to the next page. All right, we're going to take a look at somebody's income. Matt and James. All right, let's go ahead and take a look at it. All righty. It says, which situation represents the proportional relationship between what? Hours worked and amount earned. All right, for Matt and James. So as you can tell, this is Matt's. And here we're talking about James' hours worked and amount that's earned. All right, I was looking for the highlighter, but I don't know what I'm doing on this quite yet, so I'll figure it out at some point. All right, so what we'll do again is look at each one, and I'm going to tell you, you're going to take the earnings and divide it by the time, which is in hours, okay? And so that's how we're going to divide these to see if these ratios are the same. So we're going to take 12 and divide it by 1. Well, we get $12 per hour, okay? All right, let's take 20 and divide it by 2. Well, $20 for 2 hours, you're definitely not getting paid $12 an hour. You're only getting paid $10 per hour. So I can tell you right there, the match situation is not proportional. Not at all. All right, so this is a non-proportional relationship. Matt's is. Okay, let's take a look at James. Okay. So if we take a look at James, again, it's earnings divided by time. So 12 divided by 1. So right now, for 1 hour, she made $12 per hour. Here, it was $24 in 2 hours. That ends up being $12 per hour. And you all, I know you can do this. It's just divide in your head. $36 for 3 hours. So 36 divided by 3 also ends up being $12 per hour. So as you can see, since all these ratios are the same, then this represents a proportional relationship. Just that easy. All right, it says, which person, Matt or Jane, has a constant rate of pay? Okay, we've already established who has the constant rate of pay, and that was Jane. Okay, what was her constant rate of pay? Well, her constant rate of pay is $12 per hour. That constant rate of pay is also known as the constant of proportionality. Sometimes you'll hear me say COP, C-O-P, because I'm being lazy. All right. Let's take a look at this example. It says plant A is 18 inches after a week. So that's important. Let me try to find this highlighter now. See if I know what I'm doing. No, that doesn't look like the highlighter. Okay. All right. I'm not going to worry about it. All right. So this is for plant A. 18 inches after 1 week. Then it's 36 inches after 2 weeks. It's 56 inches after 3 weeks. All right, and then it says now you also have plant B. All right, plant B is 18 inches also after 1 week. It's also 36 inches after 2 weeks. Okay, but the third week is different. Instead of being 56 inches after the third week, it's 54 inches after the third week. So it says which situation represents the proportional relationship between the plant's height, and then we need to be looking at number of weeks. So these are the two things we're going to divide: height and number of weeks. Okay. All right. So let's take a look. We'll take a look at plant A. So first it was 18 inches in 1 week. So 18 divided by 1 is 18. And then it was 36 inches in 2 weeks. So you take 36 and divide it by 2, you also get 18. And then if you look at this next week, it's 56 inches in that third week. So you take 56 and divide it by 3. And I'm going to tell you guys, you're not going to get a whole number because 3 is not going to go into 56 evenly. It's some decimal. It's actually 18. I'm going to leave it as a mixed number, 18 and 2/3. And basically, I'm going to go ahead and put the units on these. This is 18 inches per week because it's talking about inches and weeks, inches and weeks, inches and weeks. This was 18 inches per week. This was 18 and 2/3 inches per week. So the amount changed. So I automatically know that this is non-proportional, which means, that plant B is, but we're going to show the work. Okay, so let's take a look at plant B. All right, so plant B. So you had 18 and 1. That was the same, which is 18. Okay, had 18 and 1. Next you had 36 and 2, which was the same as plant A, which was also 18. And then you had 54 and 3. I'm not too good at drawing these arrows, but okay, bear with me. 54 and 3. 54 divided by 3. And we also get 18. So as you can see, all of these are 18 inches. The growth of the plant is 18 inches per week. It remained constant. This is constant growth, okay? Because it was constant growth, we say it is proportional. All right. Let's go to the next example. Last one, I believe. All right, this is degrees Celsius and degrees Fahrenheit. But you all, I hope you get the gist of what I'm talking about. How to tell if it's proportional or not. You just divide and see if the numbers that you get are the same. If you do, proportional. If you don't, non-proportional. All right, let's take a look at this. It says to convert a temperature in degrees Celsius to degrees Fahrenheit. So we're going from Celsius to Fahrenheit. Then this is what you have to do. You have to multiply the degrees Celsius by 9/5. And then you have to add 32 to it. So you take whatever it is in Celsius and you multiply. All right, you multiply by what? Well, you multiply by 9/5. And then we're going to add 32 to our answer. And that will give us the degrees Fahrenheit. All right, but what we want to find out is a temperature in degrees Celsius proportional? Is the temp in degrees Celsius proportional to the temp in degrees Fahrenheit. Okay, so let's take a look at it. Want you to take Fahrenheit and divide it by the degrees Celsius. Okay, but as you can see, we don't have our table filled out. So, hey, let's fill it out. All right, so it says take your degrees Celsius and multiply it by 9/5. Well, my degrees Celsius is 0. Well, 0 times 9/5 is just 0. Then you're supposed to do what? Well, then you're supposed to add 32 to it. So add 32. So we end up with 32 degrees Fahrenheit. So that's 32. Okay. If it's 0 degrees Celsius, it's actually 32 degrees Fahrenheit. All right. Now, let's take this one. Let's take our degrees Celsius, which is 10, and multiply it by 9/5. I'm going to put this over 1. So that gives me 90 over 5, which is 18. Okay, now what do I do with that 18? Well, I take the 18 and I add what? Well, I go back. After I multiply, you add 32. So when you add 32, you get 60. So now it's 60 degrees Fahrenheit. So if it's 10 degrees Celsius, it's 60 degrees Fahrenheit. Okay, let's take a look at the next one. You take your degrees Celsius, which is 20, and you multiply it by, trying to make that look a little better, 9/5. So that's going to give us 180. 9/20 is 180. Divided by 5. So when you take 180 and divide it by 5, you get 36. But what do you get when you take 20 and divide and multiply it by 9/5? You get the 36. But what do you have to do after? Well, you have to add 32. So if you add 32, we end up with 68. Oh, let me go back. I messed up because 18 plus 32 is not 60. So let me go back and take that off. All right, so what is our 18 plus 32? Let's see, erasing my 18 plus 32 is 50 degrees Fahrenheit. Sorry. I have no idea why it's erasing my lines. So if it's 10 degrees Celsius, it's actually 50 degrees Fahrenheit. If it's 20 degrees Celsius, it's actually 68 degrees Fahrenheit. All right, let's take a look at the last one. Fill the table in for the last one. You're going to take your degrees Celsius, which is 30, and multiply by 9/5. That gives us 270 divided by 5. Well, what is 270 divided by 5? It's 54. So what are you going to do with that 54? You're going to add 32 to it. So if you add 32 to it, you end up with not 87, but 86. It's not my day, is it? All right, you're going to end up with 86. So that'll be 86 degrees Fahrenheit. Okay, but you weren't just trying to fill in the table. You're trying to see if it's proportional or not. So what we're going to do is take a look at our numbers to see if it's proportional. Our numbers in the table. All right. So taking a look at the numbers in the table, I have 32 divided by 0. Well, you can't divide by, excuse me, guys. Undo. You cannot divide by 0, so we're not even going to touch that one because we would get an impossible number. Like, it's not possible to take 32 of something and divide it by 0. So we're not even going to worry about that one. Okay. Let's go here. Let's take 50 and divide it by 10. And we all know that 50 divided by 10 is 5. Let's take 60 and divide it by 20. 68 and divide it by 20. Well, you're not going to get a whole number. You actually get 3 4/10 as a decimal. I can stop right there. I can already tell you that this is not proportional because these ratios aren't the same. I got 5, then I got 3 and 4/10. Now, had I just multiplied by 9/5 and stop, yeah, it'd have been fine. But that adding that 32 on threw it off. Just and the boat problem too. Adding $12 of gas on threw it off. It would have been proportional had it just been like the $25 an hour. But the gas, adding the $12 gas on one-time fee threw that off too. So as you can see, when you add stuff on, and it works the other way, when you take stuff away, if you add or subtract at any point, it's not going to be proportional. Like here, I'm adding 32. And on this other page, if I look at this one, I was adding, wasn't that one? It's this one right here. Like it was the boat problem. Yeah, right here. Example 3, I was adding the $12 on. It was throwing it off. That's why it made it not proportional. All right, guys. All right, that's it. If you have a chance to, just get ready to watch the next lesson. It's going to be equations and proportional relationships. And then we're going to be looking at tables and how to find missing values of tables, how to write equations for proportional relationships, how to determine independent and dependent variables, things like that. All right, that's it.